Modern air travel relies on one of humanity's most complex and awe-inspiring machines, the jet engine. These marvels of engineering are the beating heart of the aviation industry, enabling us to cross vast distances at incredible speeds. Without jet engines, the world would feel much larger, and the idea of hopping continents in a matter of hours would remain a distant dream. These engines shrink continents and oceans, making global travel routine and accessible to millions. Every day, thousands of jet-powered flights crisscross the globe, connecting people, cultures, and economies in ways that were unimaginable just a century ago. High-bypass turbofan engines, used on most airliners, are the result of decades of relentless innovation and refinement. Engineers have pushed the boundaries of physics and materials science to create engines that are not only powerful, but also efficient and reliable. Air is sucked in, compressed, mixed with fuel, and ignited, spinning turbines that power the aircraft forward. This process happens thousands of times per minute, under extreme temperatures and pressures, all while maintaining remarkable safety and consistency. Only a handful of nations and companies have mastered this technology, making jet engines a symbol of industrial might and national pride. The expertise required spans multiple disciplines, from advanced metallurgy to precision manufacturing and digital control systems. The ability to design and certify these engines is a mark of economic and geopolitical power. Countries that can produce world-class jet engines wield significant influence, both in commercial aviation and in defense. The market is dominated by giants like General Electric, Pratt & Whitney, Rolls-Royce, and Safran. These companies invest billions in research and development, constantly pushing for quieter, cleaner, and more efficient engines. Control over jet engine technology means influence over the arteries of the global economy. Every major airline, cargo carrier, and even military force depends on these engines to keep the world moving. As new powers rise, the race to master jet propulsion is reshaping the balance of power in the skies. The future of flight, and the future of global connectivity, will be written by those who lead in jet engine innovation. For years, Boeing and Airbus have dominated the skies with their single-aisle jets. China's answer is the COMAC C919, a bold move to break the Western monopoly and assert its own technological ambitions. The C919 is designed to serve China's booming air travel market and reduce dependence on foreign manufacturers. Backed by massive state investment, the C919 is a symbol of national pride and a key part of China's Made in China 2025 plan. While the airframe is Chinese, the project has relied heavily on international suppliers for critical systems. But the biggest challenge and vulnerability remains the engine. To launch the C919, COMAC turned to CFM International's LEAP-1C engine, a joint venture between GE and Safran. The LEAP engine is a marvel of efficiency and advanced materials, also powering Boeing and Airbus jets. This reliance on Western engines left the C919 program exposed to geopolitical risk. For a time, the partnership benefited both sides. China gained cutting-edge tech, while GE and Safran accessed China's vast market. But the C919's ability to fly depended entirely on a steady supply of foreign engines. Any disruption could ground the fleet and threaten China's aviation ambitions. The LEAP-1C's flow from west to east was a lifeline, one that could be cut at any moment. This dependency set the stage for a dramatic test. In 2025, as tensions between the United States and China reached a boiling point, the US government imposed a sudden and sweeping 6-week ban on exporting GE jet engines to China. This unprecedented move sent shockwaves through the global aviation industry, highlighting just how intertwined the two superpowers had become in high-tech manufacturing. The ban immediately halted all deliveries of GE engines for China's flagship C919 passenger jet, leaving dozens of aircraft stranded on assembly lines. Production schedules were thrown into chaos, and the ripple effects were felt across the entire Chinese aviation sector. The crisis exposed a critical vulnerability. China's ambitious aerospace dreams were still deeply dependent on foreign technology. After 6 tense weeks, the export ban was finally lifted, allowing engine shipments to resume. But the message from Washington was unmistakable. China's access to Western technology could be cut off at any moment for reasons beyond its control. The uncertainty sent a chill through Chinese boardrooms and government offices alike. For China's leaders and engineers, this was a sobering wake-up call. The country's aerospace ambitions, and even its economic security, were at the mercy of foreign suppliers. The realization sparked urgent discussions at the highest levels of government and industry. The incident galvanized Beijing's resolve to accelerate efforts towards self-sufficiency in jet engine technology. No longer could China afford to rely on the goodwill of foreign powers for such a critical component of its national infrastructure. Developing a world-class domestic jet engine was no longer just a technological goal. It had become a matter of national security and pride. The stakes had never been higher. The temporary ban acted as a catalyst, accelerating China's push for technological independence. Research teams, engineers, and policymakers all rallied around a single mission: to break free from reliance on Western suppliers. The future of the C919 and China's entire aviation industry now depended on the ability to develop and produce advanced jet engines at home, free from foreign control. The race for a homegrown engine was on, and the world was watching to see if China could rise to the challenge and secure its place as a true aerospace power. China's answer is the CJ1000A, a high-bypass turbofan developed by the Aero Engine Corporation of China. Intended to replace the LEAP 1C, the CJ1000A is China's best hope for powering the C919 with a domestic engine. But building a world-class jet engine is one of engineering's toughest challenges, demanding mastery of advanced materials and extreme precision. Despite progress, the CJ1000A faces years of development and rigorous certification before it can enter service. Experts agree it won't be ready for widespread commercial use before 2030. Until then, the C919 remains reliant on Western engines. The quest for self-reliance is a marathon, not a sprint. Russia too has been forced toward aviation self-sufficiency by Western sanctions after its 2022 invasion of Ukraine. Cut off from foreign technology, Russia accelerated its domestic engine programs. The United Engine Corporation pushed forward with the PD-14 for the Irkut MC-21 and the PD-8 for the Sukhoi Superjet. Sanctions, meant to cripple, instead spurred innovation and import substitution. Russia successfully flew a Superjet with entirely Russian-made components, including engines. This proved Russia could survive isolation, at least for regional jets. But scaling up production and meeting international certification standards remain major hurdles. Ambitious projects like the high-thrust PD-35 are still years away. Russia's progress sets the stage for a new kind of partnership. With both China and Russia seeking aviation independence, collaboration is increasingly likely. A joint engine program could challenge the Western aerospace monopoly and reshape the industry. China brings financial muscle and a vast market. Russia offers deep engineering expertise. Together, they could accelerate development and create a self-contained aviation ecosystem. For the West, this is a strategic threat, potentially splitting the global market and eroding the effectiveness of technology sanctions. Such a partnership would offer emerging nations an alternative to Western suppliers. The prospect of a Sino-Russian aviation bloc is no longer far-fetched. Building a commercial jet engine is one of the world's toughest industrial feats, reserved for a select few nations. The process demands not only cutting-edge technology and engineering expertise, but also immense financial investment, years of research, and a highly skilled workforce. For decades, only a handful of countries have possessed the resources and know-how to design, test, and manufacture these complex machines, making jet engine production a symbol of national prestige and technological prowess. Now, China's CJ1000A and Russia's PD-series engines are emerging as the most serious challenges to Western dominance in decades. These engines represent years of determined effort to break into a market long controlled by American and European giants. Their development signals a shift in the global balance, as new players strive to match or even surpass the performance and reliability of established Western models. The era of unchallenged Western supremacy in jet propulsion is ending. For the first time in generations, the skies are becoming a true arena of competition, with multiple nations vying for leadership in aviation technology. This new rivalry is reshaping the industry and forcing established manufacturers to innovate faster than ever before. geopolitical tensions have turned industrial competition into a matter of national security, fragmenting the once globalized industry. Countries are increasingly prioritizing self-reliance, investing in domestic supply chains, and restricting technology transfers. The result is a more divided world, where collaboration is often replaced by suspicion and strategic maneuvering. For travelers, these changes could bring both benefits and challenges. New competitors might lower airfares and increase choices, but they could also create divergent safety standards and complicate international travel. Passengers may soon find that the airline they choose and the engine powering their flight reflects not just price and comfort but also the shifting tides of global politics. Airlines may soon choose aircraft based on geopolitics as much as performance. Decisions about which jets to buy and which routes to fly could be shaped by alliances, trade policies, and diplomatic pressures, adding a new layer of complexity to the business of aviation. The C919's engine saga is a microcosm of a larger global realignment. Its journey from concept to reality has been marked by international partnerships, export restrictions, and fierce competition, reflecting the broader struggle for technological independence and influence. As China and Russia strive to join the elite club of engine makers, they're redrawing the map of global power. Their collaboration and determination are challenging the status quo, forcing established powers to adapt to a rapidly changing landscape. The roar of new engines will signal a multipolar world, where no single nation or alliance holds all the cards. Each new engine that takes to the skies is a testament to ambition, innovation, and the relentless drive to compete on the world stage. The skies, and the balance of power, will never look the same again. As nations race to secure their place in the future of flight, the world watches, knowing that every breakthrough in jet propulsion could reshape the very fabric of global relations.